Load balancers, how do they work? I think it's magical. But it's better if you can actually configure them regularly and sensibly, because load balancers, how do they work? So to help us make sense of this, we have from Red Hat, Bret McMillan and Matthew Carpenter talking about Puppet and F5.
All right. After you, sir. Hey, after you.
Hi, my name is Matthew Carpenter, and I'm a system administrator at Red Hat. I've been there for about 8 years, and currently my focus is on the customer-facing applications that we host there.
Cool. Hey, I'm Bret McMillan. Okay, you go that way, I'll go this way. I'm Bret McMillan. I've been at Red Hat for about 11 years, since 2001. I've been in a variety of engineering and IT roles, and right now I'm on the IT enterprise architecture team. So what are we here to talk to you about today? About a year and a half ago, our IT department was doing your typical hardware refresh, and we were assessing our options, and we looked at some of the equipment from F5, and we're pretty impressed. At the same time, though, we wanted to take the opportunity to take a step back and kind of reassess how we were structuring our production deployments and kind of how we walked our artifacts through to production. We engaged Puppet Labs in particular to kind of help us manage some of these devices through Puppet, and they have published the module that resulted on GitHub, so you guys can go out, fork it, check it out. I think there are at least a few people that are using it and contributing back already. This is real stuff. We're using it in production today, so it's not something that we ought, it's not a toy. It's not something that we have off in the corner and not being used very much. This talk is not going to get into the nitty-gritty technical details of managing network devices with Puppet. Nan actually gave an excellent talk earlier, and once the slides are posted, I'd encourage you to go and look there. Instead, we're going to try to help you understand what it's like to use a pretty low-level networking device module, and what are the things that worked really well for us, and what are the gotchas.
So this is a diagram of the legacy design that we had before we actually integrated the F5s into our architecture. And it's probably one that a lot of you are familiar with. For example, how many people here actually use mod proxies somewhere within their infrastructure? So a decent number. And what about mod JK? A few less, but still a lot. So essentially, we start here with a request to the site or wherever it is that you're going from the internet. You're going to hit a Cisco hardware load balancer, which is going to distribute traffic across an Apache cluster. In addition to SSL termination and that sort of thing, it's going to perform layer 7 routing, including mod proxy. And once it's figured out that logic, it's going to route you down to some application layer. That could just go through another load balancer, which will distribute traffic across application nodes. And then in some cases, you might actually hit a load balancer that's going to route you down to another Apache cluster running a software load balancer, your mod JK, so to speak. And then from there, you finally get down to another application layer. So as you can imagine, at Red Hat, there's some form of Linux that we typically use on most of our servers. So a lot of this could be puppetized already. The mod proxy Apache cluster, the mod JK Apache cluster, and all of our application nodes. What we did not have puppetized, however, were these hardware Cisco load balancers. So that was actually maintained manually by our own networking team. The thing about this design is that, for the most part, it worked. And it was a reliable design. So why actually go through the trouble of trying to replace this with the F5s?
So the first major reason was basically we kept running into some pretty significant consistency issues, right? We run
Should I just take this?
anywhere from about 4 to 7 pre-production environments, depending on the development group that we're working with. In many cases, that's a lot, and you know, the people that have many more are doing things like continuous integration, various you know, simultaneous functional test environments that are, you know, slimmed down, but there are a ton of environments. And when we're manually dealing with some pretty important pieces of our stack, it's pretty much inevitable that inconsistencies creep in. And those inconsistencies are killer in many, many different ways. You know, let's take the first. Let's just say that you've taken a, you know, a large release all the way through your staging environment, you're deploying to production, and something critically is different, right? You know, either a load balancer health check is failing, or you're getting some sort of packet loss that you weren't experiencing. How many of you guys have ever been in that kind of situation before? Okay. I know the past few times I've been on it, you know, the conversation typically goes something like this. Your networking guy looks at the app guy and says it's an app problem fault. The app guy says it's a sysadmin's fault. Sysadmin looks at a DB and says it's a DB fault, right? When you have inconsistent environments, it can quickly kind of devolve into a blame game, you know, even faster than normal, because no one has faith that the other people's stuff is the same way it was in an environment where everything worked, right? So anything manual, in my opinion, is a tremendous risk, you know, for ongoing operational excellence. The other aspect is, you know, even once you remedy some of these inconsistencies, if you've run across it a couple of times, you have this psychological fear that you know it's been inconsistent in the past, so it's probably going to be inconsistent in the future. And you start hedging your bets. You start hedging your bets in ways that dramatically increase cost. You start, you know, if you've got 4 to 7 environments, where are you doing your testing? Where are you doing your regression testing? You know, are you doing duplicative testing, et cetera? So it got to the point where we just got tired of this. Another major reason for us really taking a step back beyond just a hardware swap out was how long it was taking us to get major releases through our environment pipeline. I'd say, you know, for a medium to large project, it was not abnormal for anywhere between 2 to 4, maybe even 2 to 6 weeks to get through all pre-production environments. That's a really, really long time. I'm sure many of you do multiple releases a day. Our department, very far away from that. And one of the reasons for that is we have really, really fragmented ownership. We had really, really fragmented ownership of our stack, right? We had a networking group that owned the physical hardware, the physical load balancers. We had sysadmins who owned our first layer of proxies that did SSL termination and things like that. They also owned the Puppet master service. And then we had the production control group, who was still an ops group, but they worked a lot more with the project teams to actually get large releases out the door. This kind of led to what I like to call the project gauntlet of doom, right? I'm an applications and services guy. I'm not a sysadmin. I don't have a tremendous amount of systems or networking knowledge, but I've been in charge of a lot of projects where I've got to get, you know, the bits that my business customer care about out in front of customers. And so I found myself time and time again trying to navigate several different operational groups with differing priorities, different schedules, different efforts, different personalities. And you know, once I even got done with my initial release, if we had operational issues, if we had debugging issues, you know, we had major points of friction between, you know, the different colors on the chart, right? It wasn't fun, it wasn't easy, and it didn't let us get things out faster. It didn't let us iterate, it didn't let us make incremental improvement. And it was pretty frustrating for all involved.
One of the final major problems that we had was just simple inefficiency. Essentially, 10% of our infrastructure within production was being used to service this proxy layer, just routing traffic down to the application and serving up the content. And that doesn't really provide a lot in the way of actual business value. So what do I mean by that? Essentially what I mean is that the customer doesn't care about your proxy layer. What they care about is the content that's actually on the application tier. So when they send a request, all the layer 7 routing, the SSL termination, the load balancing, they never even see what that is. So they have no reason to care about it. And essentially, all those VMs, it was 66 in total that were serving our proxy layer, are more maintenance, more hassle, and just more trouble. Every single VM that you have is going to add extra load on your department, whether that be taking care of regular patches, taking care of monitoring, and simply responding to alerts and failures that might come up, even if it doesn't cause an actual outage in itself. And finally, because of that actual Apache cluster that we have for mod proxy, there's individual unique IP addresses that have to be assigned for each vhost on each Apache server. So eventually, we just had this IP sprawl occurring, where every single time we added a new vhost, we had to add a large number of IP addresses within our proxy VLAN. And eventually, it started sucking up IP addresses. We could have expanded the network, but why deal with a problem that you don't have to? So it's this inefficiency problem that actually led us to the F5 platform in the very beginning. It's not just a load balancer. It's what they call an application delivery controller. And it's sort of a Swiss Army knife of networking gear. There's a lot of different things that it can do for you, and it will do it really, really well. It's a load balancer. It does SSL termination. It does network compression. It will do the layer 7 routing. And you can even expand the features by using a programmable iRules. These are segments of code that are written in Tickle. And they can do anything from header manipulation to redirects, and all the way up to emulating a TFTP server. That's one thing that we saw on Dev Central, which is something similar to Puppet Forge, where you can simply go onto a website, see what a lot of the community has written, and utilize it yourself. The other thing it has is an iControl API. This is a SOAP API that you can use to programmatically control your F5 and the configurations that are stored on it. And it's this that actually allows us to puppetize the F5s, which we'll get into in just a bit here. And as I was saying, the F5s are just really, really fast and powerful. These are devices that are specifically tuned for the tasks that I just mentioned above, and they're very good at it.
Do we have anybody that actually are running F5s in production now? What do you guys think? Any complaints? Yes, yes they are. You in the back. Okay, which is that for a particular piece of hardware, or is it a? Okay. We haven't hit that one, but you know, we call it a Swiss Army knife, but it's also like a freaking chainsaw, right? These things are incredibly fast. We've seen application performance spike kind of at a minimum of about 20% when we start replacing it, and it's you know, I'm normally, again, I'm a software guy. I like software things, particularly built on top of Linux, but this was a pretty impressive piece of networking hardware, so I was pretty excited to play with it. Sorry for interrupting.
No problem. So this is the high-level design once the F5s are actually integrated into our infrastructure. And as you can see, those Apache clusters, those software load balancers, the Cisco load balancers, they've all essentially been consolidated down into 2 F5 devices and 1 virtual machine we call a Puppet proxy. So that virtual machine, the Puppet proxy, is what allows us to actually control these F5 devices. It will communicate with the Puppet master, grab the catalog that was generated for it, and pull it down, and it will convert that catalog into SOAP API calls directed towards the F5 devices. as a result, configuring them. There are two F5 devices. One is the edge, and the other is the distribution layer. The edge is going to take care of most of the logic that we have behind our routing. And the distribution is going to take care of the dumb load balancing and node membership.
Just another thing to note, if you guys haven't seen Nan's presentation on controlling Puppet devices, definitely check out the notes. We started this, I think we kind of finished out our engagement sometime in May. Puppet Labs is doing what they always do, rapidly innovating. And I think Nan's got some really pretty cool ideas that have yet to kind of manifest themselves in our deployment, particularly around some of the stuff that you can do with the storage of the facts and things of that nature. The Puppet proxy itself is the key component of this equation, right? A network device is not going to run Puppet by itself. You have to have a proxy handle that responsibility for you, and there are going to be some caveats about doing that, right? Factor doesn't work the way you think it does. You have to provide a little bit more information than you're used to in the past. But generally speaking, it's a pretty authentic Puppet experience, and it's worked well for us. So wanted to step a little bit lower and actually start talking about kind of the Puppet modules that we wrote on top of what Nan has, why we did that, what it's gaining for us. We call it libADI, which is just kind of our application delivery infrastructure. It's meant to be a pretty thin layer. It's not rocket science. One of the things we quickly found is, the iControl API that's provided by F5 is very, very rich with options. You can do a ton of different things. You can take, a couple of your members. If they're more powerful, you can send a certain increased percentage of traffic to them. iRules is a completely configurable programming language unto itself. Tons and tons of stuff. And we wanted to help. We wanted the F5 layer of the Puppet module to expose that as much as possible, so that people out in the community who might have those specialized needs can make use of it. But really, we run a pretty homogeneous shop. We don't really have a lot of these corner case needs, and we wanted a language, a syntax that we could shove down the stack towards developers and technical leads. So libADI is kind of a little bit dumber, right? It's written so that somebody like me can actually understand it and use it and be productive in it. So there are two major components. The first is what we call a libADI director. Easiest way to think of this is your typical Apache virtual host, right? So it does SSL termination. It's got an IP address and a port. It can do things like the equivalence of proxy passes, redirects, anything that you need around traffic that's incoming and might need to be divvied out to subcomponents of your architecture. Those in turn then pass the traffic back to a less intelligent layer called the libADI balancer. And this is just effectively the dumbest virtual IP kind of thing that you can imagine. If you look at our customer portal, access.redhat.com, I think we've got one director for that, and then probably about 7 different balancers, depending on which piece of the architecture an individual request needs to go on, needs to be serviced by. Any questions so far? Are folks kind of familiar with the F5 terms like virtual server, pools, etc.? Okay. What did I miss? I think I mentioned this briefly. A huge design goal of what we were trying to do is to actually have people have developers and technical leads take more accountability for the definition and maintenance of their application's architecture, right? So in the past, when we had this picture, right, you typically have a software guy who's cutting a code artifact, trying to take it through all the environments, but when it comes to load balancing, how much does he know? Does he know, whether or not his application even needs session affinity? One would hope. Does he understand, what VLAN an individual application server needs to be on? Probably not. Does he know what a VLAN is? So what we wanted to do is make the libadi syntax something that anyone who has basic resource level competency in Puppet could understand the notion that I'm laying down a vhost analog, I'm laying down proxy passes and redirect analogs, and I'm laying down some very, very simple load balancers. And that person is probably going to be more tied to a project than an operational team, right? We want our operations teams to be able to scale farther and faster and to be focused on the tough problems, right? The high value, the interesting problems. Not, how much value is it for somebody who's a top-notch admin to be screwing around with the load balancer? Not too much. So this is some of the code. It's pretty simple. Not much to it. So I haven't met a senior engineer who's typically a coder that hasn't been able to look at this, screw around with it for a day or two, and not be able to actually successfully deploy directors and balancers.
One thing I just realized that we're missing on this particular slide is for the libadi balancer portions, there should be another parameter that's required there, which is simply members. We have a function that will look up YAML files where we contain pull membership data and priority information. Once it's parsed that YAML file, it will pass a hash to the member parameter, and that's how the libadi balancer knows what pull members to utilize. Some other points that are interesting here are the include statement at the top, libadi rules. Essentially what we've done is we provided a class that will land some of the very basic default things that we are using within our F5 all the time. If you take a look at the first director that we have defined, libadi director http widgets.redhat.com, we're passing it a rule called libadi redirect SSL, which is the one that we use anytime we have a site that simply has to use SSL, and we're going to be redirecting all traffic from 80 to 443. So that director actually doesn't do too much on its own. When we actually get into the real logic, it's down at the libadi director HTTPS, which is the last resource defined here. Also, again, named widgets.redhat.com since it's a different resource type. There, we've actually defined the default balancer, widgets-default. That way, if there's no overriding logic that directs traffic to some other balancer, that's the one it's going to use, and it could, for all intents and purposes, be used as your static content balancer. The next parameter there, proxy passes, is where we actually give it the logic so it knows what URLs go to what application layers. It's as simple as providing a template file that has a class or an F5 class defining which URLs go to which balancers. And then, of course, they're required to make sure that your balancers exist before you try to define that director. We tried to make this very simple. And there are a lot of other options that you can supply to these resources, but not nearly as many as options as the F5 will actually allow you to utilize. There's still some work to be done in the F5 module as far as deploying, for example, a OneConnect profile. But for most people, it will get you through what you need to do effectively.
Okay.
So that sample code we just showed you is vastly different from the original design we put together. And we did hit a number of stumbling blocks along our way. So we just wanted to make sure that we presented some of the things that we ran into, so hopefully you don't run into it as well. The first problem we ran into was not having a very clear understanding of what we wanted the syntax to look like. You have to remember that if you're going to be putting together a module, for this application deployment, there's going to be a lot of different teams within the department using it, and it's going to be something that you're doing a lot, deploying these applications. So you want to make sure that it's as easy as possible to use, and it is what they expect it to be. So the first suggestion is simply sit down with anybody who might be using this module and simply talk about what they want it to look like. You can always define the functionality and how it really goes about doing something after you've defined the syntax and provided an interface to the users. That said, you don't want to make it too easy. And that's where we ran into the black box problem. The initial idea was to have something called libadi site, which would try to take care of all the directors, all the bouncers, all the monitors and probes, and any other thing that you might need to deploy an actual application onto your website. Unfortunately, that is just too abstract to really use effectively. When your developers sit down to write their code, they're not going to want this huge black box that is effectively an automatic car. They want to have these resources actually mapped to something they can see, for example, in that network design that we showed you a little bit earlier. If they can't map the resources to a concrete idea, then they're going to be a little lost, and it's actually going to make things more difficult for them. So that'll be the other suggestion. Don't try to do everything under the sun under one resource type. Give them the building blocks to create the application the way that they really need to, and give them the power to override things when they have to. Finally, just know what you need help with. We really, really appreciated the help that we got from Puppet Labs on this project. We have people at Red Hat who can certainly write most of the stuff that we put together, but like most people, you're probably getting interrupts throughout the day, and at the very end, after trying to plan out exactly how you want this thing to work, you're not going to have too much time left over to actually work on things. Having someone who's very experienced with Puppet and can work with the very low-level providers and resource types is extremely helpful for getting the project up and running and to a point where you need it to be.
Just a couple of additional thoughts. Again, a lot of the challenges and difficulties that we faced had a lot to do with kind of our original design intent, and that was a transfer of ownership and responsibility. Many organizations might not have that problem, right? You may have kind of a pipeline where coders code, ops folks, puppetize and can do it really quick and, work smoothly. Our environment was a little bit different. Part of that's a little bit, we've got a ton of stuff going on. Maybe we don't prioritize the best. But we really felt a need to kind of have developers engage more in the operational life cycle. DevOps, sure, maybe not full bore, but just take some ownership, take some understanding so that you know how your piece of the puzzle interacts with the other pieces. It was kind of difficult to get people to start to think about that, and that actually led in turn to design problems, right? When we talk about the importance of the pseudocode, the reason it was important was as soon as we started just throwing up sample code on an Etherpad instance, we had 5 people in a room realize at the same moment in time we were all trying to solve different problems, right? Which led to a very healthy dialogue about what the hell are we actually trying to do here, right? And I think probably 3 or 4 of the goals just dropped off the list, most of them mine. And when we started evolving it that way, things went much better. We knew what we had to do, we were able to schedule it, and then we were able to go work with Puppet Labs and really say, these are the pieces that we think we can execute well on. These are the things that are maybe a little bit out of our expertise area, right? And might take us time and might have risk, and can you really, really help us churn through this quick? Nan came on site, burned through it in an incredibly small amount of time. I think it took him in about 3 days what it had taken us about 3 weeks. So, sometimes it's important not to be shy to kind of get some fire support. So we talked a little bit about getting a bunch of people in a room, it wasn't easy. Everybody had ownership. Everybody had their piece of the puzzle. Everybody wanted things to kind of continue the way that they were doing it, right? Until they actually started talking to our business customers who were getting really, really tired of how long it was taking to get stuff done, right? So, don't underestimate the power of actually just sitting down and talking with people when you're trying to bite off a project like this. If you don't have alignment amongst your teams, if you don't have the devs willing to take some more responsibility, if you don't have the network guys understanding that their time's probably better spent designing networks versus mindlessly adding ACLs or mindlessly creating load balancers, these efforts like this are going to struggle, right? It's important not to just have the trust and alignment of the people who are telling you to do stuff, but the people that actually have to get stuff done and take ownership and accountability along the way. That's critical. The next item is GetLight, and that's probably worthy of an entire presentation unto itself. This was a piece Matt just knocked out of the park for us. It basically gives you per branch ACLs. So as part of that whole responsibility, we can now have kind of centralized repositories, have developers cut their own branches of the Puppet modules, code to their heart's content, and then start a workflow where trusted operations folks can merge into higher level development environments. We have, for every project team that we have, if they have 2 to 3 development environments, it quickly, at Red Hat at least, that's 40, 50 fractional dev environments. And it all has to run, within the boundaries of this networking infrastructure, right? So GetLight definitely from like a workflow perspective put us light years ahead of where we were. If there are other tools out there, we'd love to hear about them. We're certainly not done improving our workflow around Git, but that was a major step in the right direction for us.
And this is actually starting to progress to the point where we're getting the developers some forms of access into our production infrastructure. For example, when we need to deploy new redirects for marketing campaigns, there's one simple file that we can deploy that into, and we've given our brand people access to that so they can deploy those when the marketing campaign launches without having to go through a huge amount of mess getting it done.
Yep. So next thing is multiple environments for partition. F5s have partitions. They're a way of segmenting your load balancers from amongst each other. And as somebody mentioned, these things are not cheap, right? So if we're going to scale to double digits, and if you're a larger environment, maybe low triple-digit environments, you need to make use of partitions for segmentation, right? Just to get efficient use of the hardware. Unfortunately, those partitions have some limitations. So for our needs, we actually do multiple environments within a single partition. Pretty much strictly in the dev environment. Obviously we do not do that closer and closer to production. So creative prefixing so that you can lay the same resources down but named on the F5 device separately has been very fruitful, right? We just basically take your environment variable, tack it on to any resource that we're creating at a libADI level, and you've got side-by-side deployments. We do not manage pool member status via Puppet, right? We have other orchestration tooling, so if you need to disable pieces, our Puppet runs just don't happen frequently enough for that purpose. I'll be interested in some of the tooling that we've seen here and see if that could help matters. But right now, member creation and membership within a pool is controlled by Puppet through YAML files, but its status of whether or not it's enabled or disabled, that's outside the system. We talked a little bit about Dev Central. We picked up the proxy pass I rule, saved us a ton of work because of all the a billion vhosts that we have. Definitely, if you have more complex needs, take a look at Dev Central first. You'll probably find it. And if not, start asking questions. They've got a very healthy community, and there are user groups cropping up all over the place. Final piece of advice is try to limit the number of iRules that you're going to have per vServer. This may seem obvious to the people that are really, really experienced with F5s. We were pretty new to it, and we thought, oh, we'll just have, any programmable logic will be its own distinct iRule and be eminently reusable and awesome. It was a bitch to debug, right? So we've shifted in kind of methodology to taking iRule snippets, manage those in Puppet templates, and create a single iRule that is deployed through Puppet to your vServer. The benefit of that is when you're in development mode, you can go into your vServer, see the single rule that everything that has to do with Puppet laid down for you, and it's much more kind of deterministic to debug than 5 to 10 iRules that you're trying to figure out what the ordering, how's it executing through the different ones at different times.
So we do have a few open issues that are still remaining with the project. The number one that we have is a reliance on DNS. So when you actually land and create directories and balancers on the F5 devices, you require a DNS entry so they actually know what IP address they're supposed to have. And right now, our DNS infrastructure is not entirely self-serve. So in the development environments, sometimes the developers have to come to us to get the DNS put together so they can actually go ahead and deploy their project. Another big one is firewalls. So getting the network ACLs in place for an application still have to be done manually. In the near future, there might be other networking devices that are available to be puppetized. So that is something that might be resolvable in the near future and definitely something we are going to be looking into.
And we're very happy to hear that Juniper and Puppet Labs are working together to release some more networking device modules.
The version of the iControl API that the F5 module is written for is version 10. The reason for that is the Viprions that we're utilizing don't support version 11, or at least not yet, but they will in the near future. So it's written for version 10 right now, and version 11 has some very compelling features that are going to be useful. One of them being session persistence for logged in users. You would maybe think that if you log in as one user and log in from that same user from some other location, that wouldn't munge your session, but it does. So right now, you have to make sure that you have a lot of different users set up for individual processes that might be happening at the same time. And finally, I think we sort of touched on this a little earlier, is the Puppet dev environments. They need to be set up self-service, or we need to get to a point where they can be set up self-service. It's a little bit of a manual process, and the devs are going to have an integrated dev environment so they can actually test the F5s.
Yeah. Do you want me to take the last one?
Oh, sure.
Okay. So hybrid cloud, all that is, we have designed this module to exist within our existing data center structure. As we evolve to a much more complex topology, the intent of libADI is not to just be an F5 thing. It's meant to span a couple of different infrastructures. So, we don't necessarily have code to ship out to people. It's a thin layer. It's probably going to be pretty torn down. We're happy to share stuff with folks if you're interested. But something to be thinking about is not just what you're doing today, but also planning and abstracting what you're going to have to be doing tomorrow. F5s are great, but are we really going to run F5 VMs in the cloud? I don't know. Quite possibly not, right? We may have other proxying or load balancing devices that we want to have kind of a consistent syntax around so that, again, we can still have ownership for people that may not be familiar with the deepest intricacies of the hardware. Anyway, once these notes are posted, we've got some links. Nano's awesome. Much thanks to Puppet Labs. And if you have any questions, please find Matt or I after the chat. Thanks again.